Hello everybody, today we're going to study about modeling with quadratic functions. The learning objectives are recognize the relationship between a quadratic function and its graph, and construct and use quadratic model to predict unknown results, and interpret these findings in a real-world context. First, we're going to start with a quadratic equation in a standard form. So a functional equation of the form y equals ax squared plus bx plus c with constant a, b, and c, and with a different from 0 is what we call a quadratic equation in standard form. Why a equals 0? Different from 0, because if a is 0, we're going to have a linear function. The graph of a quadratic equation is a parabola. The meaning of the terms a, b, and c in a quadratic equation, okay, we have the equation y is equal a x squared plus bx plus c. So those parameters a, b, and c represent the following. Let's start with c. C is the value of y at x equals 0. That means the initial value. B is the instantaneous rate of change at when x is equal to 0. That means the instantaneous rate of change in the initial value. And c is 1/2 of the rate of change in the rate of change. So how the rate of change is gonna change. Okay, let's see one example. Interpreting the meaning of the parameters in the quadratic equation. In 1962, Sam Walton opened the first Walmart store. The change grew rapidly to 24 stores by 1967, and in that year, the company generated $12.6 million in sales. Today, Walmart is one of the world's premier retailers, generating $514 billion in net sales in 2019. Okay, so we have this data. We collect this data from 2006 in this case to 2019, and using a quadratic regression, we're going to find an equation. Okay, so that means that based on the data from 1996 to 2006, the net sales of the Walmart can be modeled by the equation, by the quadratic equation. S of t is equal 0.8636t squared plus 14.39t plus $84.72 billion, where t in this equation is the number of years since the end of 1996. But what is S of t? Okay, S of t is the net sales in billion dollars since the end of 1996 to 2006. Okay, so the question is, explain the meaning of the parameter of the model in the real world context. That means explain the meaning of A, B, and C. So remember the meaning of A, B, and C. C is the value of y at when x is equal to 0, that means initial value. B is instantaneous rate of change when x is 0, and A is 1/2 of the rate of change in the rate of change. That means that the rate of change in the rate of change is 2a. Okay, so we have A, B, and C. So then we have to explain the graphical meaning of those parameters. What is A, what is B, and what is C? But remember, we're going to start with C, then with B, then with A. So we have our equation, quadratic equation. So since C is $84.72 billion, remember that the model estimates that Walmart earned $84.72 billion in revenue in 1996. B is $14.39 billion per year. Okay, that means that the model estimates that at the end of 1996, Walmart sales revenue was increasing at a rate of $14.39 billion per year. Okay? At the end of 1996. But now, A is 0.8636, right? So the model estimates that the increase in revenue is increasing at a rate of $1.73 billion per year each year. Why 1.73? Remember that A is half the rate of change in the rate of change. So that means that the rate of change in the rate of change is 2A. That is 2 times 0.8636, which is approximately $1.73 billion per year each year. We have again our model. So that means that since the revenue was increasing at the rate of $14.39 billion per year in 1996, we expect that in the next year, that is in 1997, revenue will be increasing at the rate of about $16.2 billion. That is 14.39, which is the rate of change, plus 1.73, which is R, which is equal to 16.12. Since C is 84.72, the vertical intercept of the parabola is 0, 84.72. Remember the initial value when t in this case is 0. If t is 0, it's going to be 0, 0. So our initial value is going to be 84.72. B is the slope, which is the rate of change of the parabola at the vertical intercept is 14.39. Since A is equal to 0.8936 and this A is positive, okay, it's a positive number, the rate of change is itself increasing, which means that the parabola is concave up. So look now the graph. If we graph this, the parabola is concave up if A is positive. In this case, A is positive, so our parabola is going to be concave up. If A is negative, the parabola is going to be concave down. So because A is positive, we're going to have a parabola concave up. Because our initial value is 84.76, that means at the end of 1996, we're going to have $84.72 million. Remember, while the function is concave up, the rate of change is increasing and vice versa. This is everything for today. Thank you very much. Our source is Modeling with Quadratic Function, the book College Algebra. Make it real, Chapter 4, Section 4.2, page 249. Thank you.